Right now, somewhere out in the freezing dark of deep space, a dead star turned into an invisible monster is moving at 3 million miles per hour, and it is heading straight toward a star that has no home. What happens when two completely lost objects in the universe finally meet in the absolute dark? There's one detail almost nobody talks about. Back in 2022, astronomers using the Hubble Space Telescope found something that shocked them. They caught a rogue black hole drifting through our galaxy, about 5,000 light-years away from Earth. It weighs as much as 7 suns, but it has no solar system and no companion star to light it up. It is floating through space entirely alone. Could there be millions more of these invisible drifters hiding right in our cosmic backyard? That's when the math gets terrifying. If a black hole is completely dark, how would you ever know if one was coming for a rogue star right next to us? You see it by looking for a bend in the sky. When a wandering black hole passes in front of a distant light, its massive gravity acts like a giant magnifying glass. It bends and stretches the light behind it. Scientists call this gravitational microlensing. That is how Hubble found the lone black hole in 2022. It didn't shine. It just warped the background stars for a few short days and then vanished back into the blackness. Now, think about the rogue star. These are real stars, often millions of times brighter than our sun, that got kicked out of their home galaxies. Maybe two giant galaxies crashed into each other, or maybe a supermassive black hole at a galaxy core flung the star into space like a slingshot. These runaway stars travel through empty space for billions of years. They carry no planets, no solar system, and no heat from anything around them. They are completely alone. So what happens when a wandering star meets a wandering black hole out in the middle of nowhere? You might think the black hole just swallows the star whole, like a vacuum cleaner. But that is not how gravity works in space. Space is big, and black holes are relatively tiny targets. Most of the time, the star does not crash straight into the center. Instead, as the star gets closer, the gravity on the front side of the star becomes millions of times stronger than the gravity on the backside. The black hole literally pulls the star apart like dough. Scientists call this a tidal disruption event. The star gets stretched out into a long, thin stream of hot gas. Half of that gas gets thrown out into the void of space forever. The other half gets pulled into a spinning ring around the black hole. As that gas spins faster and faster, heading toward the point of no return, it heats up to millions of degrees. Suddenly, a region of space that was totally dark for billions of years lights up with a flare brighter than 100 billion suns. It flashes like a giant cosmic light bulb in the middle of nowhere. But that's not even the strange part. What if the black hole misses? What if the wandering star doesn't get pulled apart, but just barely grazes the edge of the black hole's gravity? When that happens, the star doesn't die, it gets accelerated. The gravity of the black hole acts like a cosmic whip. It grabs the wandering star, swings it around in a sharp turn, and shoots it out into deep space at speeds over 4 million miles per hour. Scientists have actually found these hypervelocity stars speeding out of our galaxy. They are traveling so fast that the Milky Way's gravity can never hold them back. They are doomed to wander the empty void between galaxies forever. Now, let's zoom out for a second. Our own sun is traveling through the Milky Way at about 450,000 miles per hour. It takes us 230 million years just to make one full circle around the center of the galaxy. But the space around us is not empty. There are estimated to be over 100 million stellar mass black holes roaming around our galaxy right now. Most of them were created when big stars died billions of years ago. They are invisible, quiet, and fast. If a rogue black hole drifted into the outer edge of our own solar system, it wouldn't even need to swallow Earth to destroy us. Its gravity would pull on Jupiter, disrupt Neptune, and yank Earth right out of its warm orbit around the sun. We would become a wandering planet, drifting alone in the freezing dark, just like those lost stars. How close would an invisible black hole have to get before we noticed our sky starting to bend? Scientists are scanning the sky every single night with new telescopes, looking for tiny blips in light, proof that an invisible giant is passing by. But out in the deep space between galaxies, where there are no lights to bend, wandering black holes and wandering stars meet in total silence. They clash, light up the universe for a brief second, and then fade back into the endless black.